That is the maximum. కరెక్ట్ గానే ఉందా? మామూలుగా మీరు చెప్పేది మామూలుగా సఫిషియంట్. నార్మల్ క్లాస్ కాదు, నాది ఎలా పీపీటీ వస్తుంది కదా, నా ఈ స్క్రీన్ లో ఈ లెటర్స్ సరిపోతాయి కదా. గైస్, ఆర్ యూ ఫేసింగ్ ఎనీ డిఫికల్టీ? ఇస్ ద స్క్రీన్ ఇస్ క్లియర్? ఆఫ్లైన్ స్టూడెంట్స్, ఇట్ ఈస్ బ్లరింగ్. Okay, just give me 2 minutes. Here that is not problem, there only. Yeah, online students wait for 5 minutes. There is small technical issue at offline. Is this clear, right? This one also clear? Is this a blur? Clear, right? Last. For everyone, it is clear. Code also clear, right? Done. Let's continue then. Okay. So let's start the session, guys. So coming to the today's class, we are going to start classification. Now coming to the classification, it is also a supervised machine learning. It is also a supervised machine learning approach where we are going to divide where the output variable consists of. The output variable consists of discrete categories. The output variable is discrete variable. Okay. So as we know, the cross-sectional data, any cross-sectional data consists of continuous and discrete. Cross-sectional data has continuous and discrete. If your output variable is continuous, if your output variable is continuous, then it is called as a regression. The same output variable, if the output variable is discrete, whether it is a discrete count or discrete categorical, if it is a discrete, then it is called as classification. If the output variable is discrete, then it is called as if the output variable is continuous, then it is called as regression. If the output variable is discrete, then it is called as classification. So either we are going to have continuous or discrete, only two options in the output variable, because any cross-sectional data consists of either continuous or discrete only. For time series data only, time series variable will be added. For other than time series variable, any cross-sectional data will have either continuous or discrete. Only two options we are having. The input can be anything. There is no problem in the input. In this case, whatever the input can be continuous, discrete, whatever it is. Here also the input can be anything. There is no problem with the input. Input can be anything. Input in this case or in this case, input can be anything. But whereas output in the regression algorithms, the output is continuous. In the classification, the output is discrete variable, right? Now, this is also a supervised machine learning because we are having the output variable. If there is an output variable, then it is called as label data. For the label data, if you apply any kind of machine learning techniques, then it is called as supervised machine learning, right? And here the target variable is a discrete variable. Now here, if you observe this one, we are having some input columns, and based on the input columns, we have to say whether the person is going to default or non-default. We are having only two categories in the output variable. Now what is the difference in the regression versus classification? Regression and classification. In the output, since the output is continuous in the regression, now whatever you are predicting, the predicted value can be anything. 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 For example, you can predict 1400, 1402, 1404.2, something, and 1405.1, 5.9, some 14, like this. You are going to predict any value. That can be anything out of infinite number of values. Out of infinite number of values, it can be anything. But whereas coming to the classification, the output is discrete. Since the output is discrete, it is having a fixed categories. Discrete variable means fixed number of categories are there. And whatever you are going to predict, the predicted value can be of these categories only. You have to predict out of these categories only. You can't predict as per your choice. They are not infinite values. For example, in the train data, if you are having the output variable yes and no, you have to predict the output also yes or no only. For unknown data, you have to predict whether the person is going to default the loan or not default the loan, whether the person will get the job or not get the job, whether the person will leave the company or not leave the company. If in the input variable, whatever the classes are there, in that only you have to predict. For example, in the input variable, for example, let us take train data. In the train data, in the train data, you are having the output variable, which consists of either the person is going to default the loan, yes or no. Only two categories are there in the train data. Okay, you are predicting on the unknown data. Once you have trained on the model and now you are predicting, the model should predict the answer either yes or no. It can't say that average or 50-50, 60-40. It can't say like this. The answer is fixed, either yes or no. Tell anyone. Fixed answer, lock. So in the output variable, we are having a fixed number of categories. Now, for example, it is a discrete count variable. Then also we are having the fixed categories. For example, the number of mobile phones. That is 0, 1, 2, 3. We are having the number, fixed number. So in the output variable, we are having the fixed number of categories, and we have to predict also these categories only. We are not going to predict any new category. We are not going to create any new category. Already whatever the existing categories are there, with that we are going to predict. Now, how it is going to predict whether that category or this category, that is the algorithm. In the each algorithm, it is going to work in a different way. Now here, if you observe this one, here I'm having the output variable where I'm having 0 and 1, only two. This is the train data, which was given for training for the machine. Now the machine will be trained on this. If this is the input, this is the output. If this is the input, this is the output. It will train. Once it has got trained means we are going to give to a machine learning algorithm, and the machine learning algorithm, first it will make a model. First it will create the model. Once the model was created, now for unknown data, if I pass this information to the model.predict. Yesterday's class I have shown you, right? Model.predict on a new data in the lasso regression and in the elastic net regression. Model.predict on a new data, how it is going to predict. Of course, that new data first to be transformed. After transformation, if it is having some kind of text data, we have to do encoding. After that only we have to give to the model. But once you share to the model is going to predict the answer either 0 or 1. Because you have trained the model with zeros or ones only. So it is also going to predict the output as either 0 or 1. It is not going to predict with a new value. It is going to predict with the same value, either zeros or 1. Is that clear, guys? Now, if you are having an output variable only two categories, then it is called as a binary classification problem. If output variable consists of two categories, exactly two categories. If the output variable consists of exactly two categories, then it is called as a binary classification problem. Then it is called as binary classification problem. And as per that problem, we have to apply the algorithms which are applicable for binary class. Next, if output variable consists of more than two categories, anything, either 4, 5, 6, whatever the number in the output variable, then it is called as multi-class problem. Multi-class classification problem. Binary means I'm having binary class, only two classes. Multi means multi-class, multiple categories are there. Sir, in the output variable only one class is there, then here more than two categories means okay. Exactly two categories also okay. If you are having one category means, then you no need to predict. Answer is that one only, right? Why to predict? Why to do anything? For one category, no need of prediction also. The answer is locked. Everything are 1, 1, 1, 1, 1, 1, 1, 1. What is the answer of this one also? 1 only, obviously. Why to predict? Why to do anything? No need to do anything. Directly only we can say the answer. Right? Minimum two classes should be there. In the output variable, one class is there means no need of classification algorithm, nothing is required. Is that clear? Now, if it is a binary class means according to that, we are going to apply the binary classification algorithms. If it is a multi-class, we are going to apply the multi-class classification algorithms. Right? Now, next. If you go to the next one, So here I'm having with respect to multi-class example. So here based on the age, gender, and based on the BP and cholesterol level and sodium and potassium percentage, the drug, we have to predict the drug, right? So in the output variable, what you have to predict means drug for a particular patient. This is the output variable. For example, one person has got fever. Assume in real life, one person has got a fever, normal fever. What generally we'll do? We'll take directly Dolo 650 blindly. But Dolo 650 is not suited for everyone. Fever, along with the fever, what additional you are having? Only fever you are having, or along with the fever, you are having some kind of warm things or some kind of any body pains or headache or with respect to stomach pain or something. Is there anything along with that, or only purely only fever? So, and if you are having only fever only, assume that you are having only fever. At the same also, we should not take directly Dolo 650 because Dolo 650 is well suited for the people whose weight is more than 70 kgs. As per that particular, whatever the medicine prescription is there, if you read that particular medical prescription, in that they will write clearly 650. This 650 means some kind of, we are having the value, right? 650 means what is the 650 in terms of, okay, whatever the mg or whatever it is having, that amount of quantity is well suited for which persons. That according to that we have to take. For example, it is your body weight is very low, or means you are a children, your age is less than 12 years. It is not advised to go with 650. It is better to go with the 325, means half of that. They'll ask to take half tablet. So it completely depends upon the person to person. It is not blindly for every person, right? Example I'm saying. Exactly, I don't know. Example I'm saying, right? Don't decide based on this. Don't take the tablet. Example, purely example, right? But I know very clearly it depends on tablets are nothing but chemicals. I know this one. 100% I know this one. Tablets are nothing but chemicals. In my body also I'm having chemicals. Body is having chemicals, and this is tablet is chemicals. When this tablet enters into my body, some chemical reaction happens. 100% I know this one. 100%. Not example. Really I know, right? So the tablet is having some chemicals, and my body is also completely, body is chemical body. Inside that complete chemicals are going on. Blood is chemical. Everything is a chemical. Inside whatever I'm having, everything is a chemical. Calcium is a chemical. Potassium is a chemical. Whatever the sodium is a chemical. And with respect to whatever we are having additional sugar, beef, whatever, everything in the body, whatever the minute part is there, every part is filled with chemicals. That everyone knows. And what are the tablet I'm going to take? It is also a chemical. And when both the chemicals react, when both the chemicals combine, automatically some reaction will happen. This one also everyone knows. So how we can take as per our choice the chemicals? We should not take as per our choice. Directly, we should not take the medicines as per our choice. Someone who are already familiar with that one, they have to suggest us. In the least case, medical shop owner at least. He is having some kind of B pharmacy idea, or if he's an experienced person in having dealing with the patients or something, minimum we have to take from him. Okay. Or mothers, they are already experienced from our childhood onwards. They are saying what about the different types of diseases we used to have and what are the tablets they have given to us and which is best suited for our body. Also, they knows everything. So the mothers are best doctors for us basically. And but here coming to this, what I want to finally confirm is tablets, whatever the tablets are there, these tablets are not for everyone. Every tablet is not for every common person. Every tablet is not for every person. Based on the body composition, based on the body, within that, it depends. Right? So here, the same thing what we are having. Now, so age, gender, BP, cholesterol, sodium percentage, potassium percentage, based on that, we have to predict the drug. What are the drug is there? So as percentage, sodium percentage is high, we can't go with certain tablets because the reactions will be a different one, right? So based on the different body compositions, person to person. For example, if you case my case only, though I'm having heavy body pains also, I should not take the body painkillers. I'm having some kind of disease internally. My body will not support any kind of painkillers. If I take any painkiller, next day morning, I'm going to have another problem. This is my internal body composition. I should not take any kind of painkiller. Though I'm having any pain also, I should not take. Then what type of painkiller you have to take if something happens or something when unexpected events will happen suddenly, right? In that case, what happens means doctor has told that there is a particular medicines for your body. At that time, we are going to inject that one. For a normal general level daily usage, whatever the general persons will take the body pains, for that they are going to take some tablets generally, right? That you should not take. General medicines you should not take. Doctor has suggested me in that way, right? So that after diagnosing only, he has identified that one. Before diagnosing, who knows that one, right? Here, whatever the drugs are there, these drugs are completely based upon the body composition, completely. So here, drug X, drug Y, and drug C. 3 drugs are there. In the output variable, if you see the unique categories, 3 drugs are there. X, Y, and C. Drug X, drug Y, drug C. And since it is a multi-class classification problem, so I'm going to give for a model which supports the multi-class, that is decision tree algorithm. This is one of the algorithm, which is the which supports the multi-class. So now using this algorithm, I'm going to predict on unknown data, whether it is a drug X or drug Y or drug Z, right? I'm going to predict either drug Y or drug Y or drug X or drug C, CXY. CXY. Out of these 3 only I have to predict. I can't predict a new one. Out of these 3, if I ask what is the best one, miss, you have, for each of them, for example, sir, out of these 3, instead of these 3, 4th one is the best one, sir. Forget about the 4th one. Within these 3, tell me which is the best. Within these 3 miss, okay. Then within these 3 miss, more probably this is might be best. You are saying like this, which is having the high probability, that one only we are going to select. Just in the backend, it is going to apply the probability concept, right? So which is having the higher the probability, just it is going to select that one. Which is having the least probability, it is going to ignore. Higher the probability, it is going to select, right? Now, the next one we are having is use cases in multiple companies. Almost in the real life, 90% of the companies, whatever applying the ML algorithms, everyone are using classification only. Okay, so classification, whether the person will join the company or not join the company. If you release the offer letter, sir, if you get the job, miss, I will join, sir. Miss, that is precious. That is okay. Experienced people, already they are having certain amount of experience and they are already having 6 lakhs package, assume. And the new company has given only 6.25. Miss, 25,000 extra, 6.25. Whether this person will join for that 25,000 per annum, 25,000 miss, per month 2,000 rupees as an increment. So whether this person is going to join or not going to join, there will be certain people who will join for that one also. There will be certain people who will not join. For example, in the previous company, you are not having a good rapport with your seniors or with your colleagues. Then what you will do? You will just jump into another company, right? Though you get a light increment also, if you don't get increment also, you'll jump sometimes. HR will understand everything. They'll ask you the question, why you are shifting from that company. At that time, they'll understand the reason behind that. And clearly, they'll discuss recently whatever the project you have discussed and you have discussed with your seniors, means what they have told you. Like this, they'll analyze about very clearly. And based on that, the salary negotiation will be completely. Right? Now here, whether the person will leave the company or not, yes or no. This is called as churn modeling. Churn, CHURN, churn modeling. Churn modeling means whether the person will leave the company or not. HR analytics. This project belongs to HR analytics. HRs generally will do that one. They'll check every time whether the person is going to continue or not. Right? They're called as churn modeling. Next, the most important one is called as your mail classification. You are going to get every mail, and in that mail, few mails you'll get into the spam, few mails you'll get into the inbox. And within the inbox, that too, we are having primary, social, promotion, update, and forum, something. Now in this, we are having the multi-classes. Now, if I send one mail for you, in which one you are going to receive that one, either in update or in the promotion or in the primary or directly into the spam, into which I'm sending a mail for you, a normal mail for you. Then from where it is going to go, whether into the spam or whether it is into the normal, everything in the backend of Gmail, ML algorithm is there. The entire Gmail, whatever you are saying, the Gmail in the Gmail backend means whatever the website development and whatever the things are there, everything is there. But I'm discussing only about the mail classification, whether the mail belongs to a spam mail or whether the mail belongs to a normal mail. That is purely of the ML algorithm, classification algorithm. It is a classification algorithm. Why Gmail is having a high accuracy? With a high accuracy, it is predicting and it is separating the data easily. Means it was trained with respect to large amount of data. Earlier, when the Gmail has started initially, it is not having that much of accuracy. We used to have everything. I used to work on Gmail 5-6 years back. When in the year of 2016, when I am using the Gmail, I used to get most important mails also in the spam mail sometimes. Sometimes unimportant mails also I used to get in the normal mails. Okay, when they have started that classification, initially they are not having that much of accuracy levels. As you train the data more amount of data you have given for that, then automatically accuracy has been increased. They have done with respect to by increasing the data every time. Now, whatever the ChatGPT we are having in the market presently, and the ChatGPT also works with respect to the same in the backend. There is a, whether it is ML or deep learning, the concept remains same. ML means ML algorithms, DL means DL algorithms, AI means AI algorithms. Algorithms change, but concept is not going to change. If there is an output variable and that output variable consists of discrete means 100% classification only. Whether you apply AI, whether you apply DL, whether you apply ML, or if you apply whatever you want. Classification means classification only. It is not going to change. Only algorithms change. Instead of ML algorithms, you are going to use the deep learning algorithms, that is neural networks. Using the neural networks, you are going to create, right? Deep learning and artificial intelligence means nothing but neural networks. So the ChatGPT was created using the neural networks. But concept remains same. It is a classification algorithm. It is identifying the classes. In that, if you ask any particular question related to classification, it is working based on the classification, right? So all these things. So as I have told you, this one is Chen modeling, and this one, this example related to Gmail classification, whether your mail is a spam mail or a normal mail, this one, and Chen modeling, and multi-class classification problem, and binary classification problem. So these four of them I'm going to show you during the algorithms. So one project we are going to work on the binary classification. One project we are going to work on the multi-class classification. One project we will work on the spam classification, whether it is a normal mail or a spam mail. That one we'll check. And one we are going to work on the Chen modeling, whether the person is going to quit the company or not. So we are going to discuss all these one by one projects in the upcoming sessions. Now, coming to this, if the output variable, just now let us take like this, just write in the notes very clearly after once my completion, once I have completed, not now, right? In your original data, Y, in your original data, Y, whatever the Y you are having, the Y you are having either yes, no, yes, 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 no, yes, no, yes, 3, 6, 9, 10. Okay, something you are having the original data like this, yes and no, yes and no, something. Now you are going to use your model, and using your model, you are going to predict. So if you predict, you are going to get an answer also either yes or no only. You are not going to get anything else. Now, how to calculate in this case error? If it is wrongly classified, then how to calculate the error in this case? Same as earlier, how we have applied. So first, for example, let me convert this particular one to encode. I'm doing the encoding. And in the encoding, if I do, automatically no will become as 0, yes will become as 1. because alphabetical order n will come first, followed by y. So 1, 1, 1, 0, 1, 0, 1, 0. Now, if my machine has predicted answer as 1, 1, 1, 1, 0, 1, 1, 0, 1, 1, something it has predicted like this. Now, I'm going to calculate y minus y hat. From that, I'm going to calculate y minus y hat whole square. And from that, I'm going to calculate mean square error like this. Means no, this logic we are not going to apply. The entire evaluation metrics of classification is entirely different. Completely, it is different. It is not similar kind of what we are having for the regression. Regression evaluation metrics are different. Classification evaluation metrics are completely different. We are not going to do y minus y hat whole square, and for that we are not going to apply the mean. That is, we are not going to calculate the mean square error or root mean square error, or we are not going to calculate the R square also. Because to calculate R square, first we have to calculate average. From where I have to calculate average? Sir, earlier this is converted as 1. For example, predicted also 1. Error is 1 minus 1 na. 0 na. Happy only, right? This is encoded data, right? Not the original data. Original data is yes, and this one is yes. Yes minus yes. Okay, 0. No minus yes. Then how you are going to calculate? Original data. Think about the original data, not the encoded data. Okay. For the original data, we can't do all these things. For the original data, how you can calculate y bar? For example, you have got the y bar as 0.6. Okay. You have converted everything as 1, 1, 1, 0, something. You are having total 6 ones. So 6 by 10, which is equal to 0.6 assume. Now, how this y bar will be considered as a 0.6 what is the meaning of 0.6? So this logic, whatever the mean value, median value, or with respect to skewness value, or range value, variance, standard deviation, when I'm discussing about this statistics, descriptive statistics, I told that these all of them are applied only on the continuous. For discrete variable, we are having one and only called as mode. We can't apply the variance concept, range concept, standard deviation concept, or any other concepts to the even probability. Also, we can't apply for the this one. We can't apply the Z-score. We can't apply the Z-score, and from that Z-score, we can't calculate the probability. So for discrete variable, if you want to calculate the probability, then directly you have to see the data only. Either the data from the plot, for example, yeses are there 6, nos are 4. What is the probability of S means? 6 by 10, which is nothing but 0.6. What is the probability of no miss? Which is nothing but 4 by 10, which is 0.4. So here we are going to calculate for each category the probability separately. But whereas in the continuous variable, we have calculated for an interval. What is the probability from 10 to 20? What is the probability of a single value? What is the probability of a single value? 0. So probability of a single value for continuous variable, it is going to be 0. The probability of a single value for discrete variable, it will be having certain value. What is the probability of average? In this data set, what is the probability of average miss? Not there. So 0 by 10, which is 0. For every category, the probability will be there. Okay, if the probability is having value miss value, if the probability is not having the value miss 0. Right? Now, here, the entire process, the discrete variable, the concept is entirely different. We can't apply the same logic of whatever we have done for the regression algorithm. So here the entire concept is different. So if you're having the original y, yes and no's like this, and model has predicted the values like this. Yes, 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 no, yes, no, yes. No, yes, no, yes, yes. For example, your data was predicted in this way. Okay, that is the original y, and this is the predicted y. Now, just you are going to observe how many of them are correct. In this, how many of them are correctly classified? The original is yes. Model also correctly classified as yes. Yes, correct. Original answer is no. Model was predicted as yes, which is wrong answer. Wrongly predicted. Model wrongly predicted that one. This one correctly predicted. This one correctly predicted. This one wrongly predicted. This one correct. This one correct. This one correct. This one correct. And this one is wrong. Total how many wrongs are there? 3 wrongs are there. Now what is the accuracy? Accuracy means correctly predicted divided by total predictions. This is called as accuracy. Means your model has predicted with 70% accuracy. Out of 10 records, 7 records are correctly predicted. What is the misclassification? Wrongly classified. What is the misclassification rate? Misclassification rate is equal to 3 by 10, which is nothing but 0.3 or 30%. 30% of the records are wrongly classified. 70% of the records are correctly classified. This is the evaluation metric which we will do in the classification. Okay, example. Right now, please take the data set, and for this data set, we'll do all the evaluation metrics one by one. Consider the data set. Okay, so let us take one data set of your choice. Let's try with like this COVID example. This COVID example will help us to understand this evaluation metrics easy. The advantage of COVID is one of the advantages this one. Okay, so COVID. So original data, actual data. Okay, actually the person is having the COVID positive or negative. Let us take like this. The person is having positive, negative, 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 positive, negative, negative, positive, negative. 1, 2, 3, 4, 5, 6, 10. Total 10 records. I'm taking 10 records for simple calculation purpose. Instead of dividing every time with 11 or 12, it will be coming in the, again, I have to open the calculator. Instead of that, I'm taking a simple example. Now, you guys, let us, instead of fixing everything, let us, without seeing this one, okay, whatever I have written there, without seeing that, just can you tell me few values as per your choice, whatever you want. Predicted values as per your choice, either positive or negative. Only you have to use 2 words. Tell me as per your choice, whatever you want. Huh? One student, anyone? Guys, continue. Tell guys. Because why I'm saying this one is, for this random data, we are going to do the complete calculation. Instead of selecting bias by seeing that one, if I write the same thing, there may be a high probability that high accuracy will get. 3, 6, 11. 11 are there. 3, 6, 10. Okay, done. This is original data and this is the predicted data. Okay, now we are having each record like this. First record, second record, third record, fourth, fifth, sixth, seventh, eighth, 9, 10. Total 10 records are there. Randomly we have written. For this randomly, whatever the data was written, write in your notes. Write the data set in your notes so that we'll do the calculation, evaluation for this. Assume that this is the original data and model has predicted this one. Any algorithm, whether the algorithm might be anything, it has predicted in this way for this data set. Then how we are going to calculate the evaluation, how we are going to do the evaluation for the model, whether our model is a good one or a bad one. Done. So let's start with the first one called as accuracy. The first evaluation metric is called as accuracy. Now, what is meant by accuracy means correctly predicted, correctly predicted records, correctly predicted records by total number of records. Total number of records is called as accuracy. How many correctly predicted? Let us see. Wrong, correct, wrong, correct, wrong, correct, wrong. 1, 2, 3, 4, 5. 5 of them correctly predicted, 5 of them wrongly predicted. So which is equal to 50% accuracy or 0.50, or which is equal to called as 50%. Right? Is that clear? So 5 records are wrongly classified, 5 records are correctly classified. Okay. What are the randomly given by the students? For that, it is 5 of them are wrongly, 5 of them are correctly classified. Now, second one is misclassified records. Misclassification rate. Misclassification rate. Accuracy is also called as classification rate. Accuracy is also called as classification rate. And now misclassification rate. Misclassification rate means instead of writing the word correctly, incorrectly predicted. Incorrectly predicted records divided by total number of records, which is equal to 5 by 10, which is 0.5. Again, it is also equal to 50%. In this case, both are same. Right? This is the first one and this is the second one. First misclassification rate followed by this. Now, once this is completed, now the next one. Confusion matrix. One of the most important, and you should not get confused. Right? Already whatever we have done the same thing in the hypothesis test. In the hypothesis test also we have done the same. Now, just I'm going to create a matrix. One side actual, one side predicted. Choice is yours. You can take as per your choice. In Python, if you ask confusion matrix, by default, it will take actual this side. By default, actual this side. And it is going to take predict this side by default. If you want, you can interchange also, not a problem. By default, it will take like this. Now, in the predicted, you are having two classes, that is positive and negative. In the predict also, you are having two classes, positive and negative. In the actual table, if you see the actual column, in the actual column, you are having either positives or negatives. In the predicted column, if you observe, you are having positives and negatives. What are the classes are available in the actual class? What are the classes are available in the predicted class? Now, this particular record says that actual value, this particular cell indicates actual value is positive and predicted also positive. This cell indicates what is the actual? Actual is positive, predicted is negative. This cell indicates actual negative, predicted positive. This cell indicates actual negative, predicted also negative. Now let us observe how many records are there with actual positive and predicted positive. Actual should be positive and predicted also positive. Actual positive, predicted positive 1. Actual positive, predicted positive 2. Total 2 records are there with actual positive and predicted positive. These are the 2 records. Next, I'm trying with a different color. Actual positive and predicted negative. Actual positive and predicted negative is 1. This is the 1. Next, actual negative, predicted positive. Negative and positive. 1, negative, 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 positive. 2, negative, positive. 3, negative, 4. Total 4 records are there. And how many records are actual negative and predicted also negative? 1, 2, only 2. Oh, this is 3. 3 records. Now if you total 0, 2 plus 1, 3, 3 plus 4, 7, 7 plus 3, 10, 10 records. Now in your data set, how many actual positives are there? Means if you add like this, how many actuals are there? 0 plus 2 plus 1, which is nothing but 3 records. 3 records will be actual positives. 1, 2, 3. Yes, satisfied. How many actual negatives? Actual negatives I'm asking. That is 4 plus 3, 7. 1, 2, 3, 4, 5, 6, 7. 7 records. Satisfied? Similarly, predicted positives. Predicted positives means you have to add in this way. If you add in this way, 2 plus 4, 6. Check only in this particular column only you check how many positives will be there. 1, 2, 3, 4, 5, 6. How many negatives are there? 1, 2, 3, 4. So with respect to total is 4. Is that clear? The confusion matrix is clear. Anyone having any doubts on the confusion matrix? So just you have to create a matrix and you have to take actual and predict. And first this cell, what this cell indicates, you have to understand. And for that cell, how many records satisfies, count that records and write the number. Whatever the cell, whatever the inside that it is there, irrespective. Okay. Is that clear, guys? Online students, any questions? Yeah, it is in the hypothesis test also. We have already completed the same thing. In the hypothesis test also, we have done the same thing. Accept the null hypothesis, reject the null hypothesis. And there incorrectly accepting the null hypothesis is called as type 1 error. Incorrectly rejecting the null hypothesis is called as type 2 error. Right? The same way. Here also the same. Same confusion matrix, same errors, but instead of using the word called as null hypothesis, we have to use a different word here. That is the only difference. Remaining everything is same. Anyone having any doubt in the confusion matrix, how to create for a given data set? Once the actual values and the predicted values, if both of them are available, then only we can create a confusion matrix. For only actual data, we can't create the confusion matrix. Okay. If you create only for actual data, means you can get only these with respect to if you create an actual. So actual yeses are there. Actual how many yeses are there means 3 yes. Actual how many no's are there means 7. So you can create only this last column. You can create only the last column if you are having the actual data with you. When you are having the predicted data, then only you can create a matrix. Is that clear? If it is clear, write in the notes. If it is not clear, ask your questions, whatever the doubts you have. Because for the next 10 days, we are going to work on the confusion matrix. If it is not clear, next 10 days, it will be difficult only to understand. Okay. Coding part will be dead easy. Just you have to import the confusion matrix, and in the confusion matrix, you have to provide the actual data, predicted data. That's it. Just 2 lines of code. One is import from sklearn.metrics, import the confusion matrix. And within the confusion matrix, you have to give 2 input data. One is actual data, one is predicted data. If you give these 2, it will compare both of them and it will create the matrix like this. That's it. Right? Coding part is of just 2 lines, but how it has created, that is more important. right? And in this now coming to this confusion matrix, in this confusion matrix, we are having with respect to the first one called as this particular cell, actual positive and predicted also positive, is called as TP. TP means true positive. This is called as true positive. So next one, write in the notes heading as true positive. Now true positive. So true positive, false positive, true negative, and false negative. Total we are having 4 of them. First one is true positive, which is TP, false positive FP, true negative TN, false negative FN. Total 4 we are having. Okay, total 4. No, for multi-class also. We'll do that one also. Okay, for multi-class also same to same. And second, it is not only for positives and negative words. It will even apply for the everything. Okay, that also we'll see. Guys, of online students, just wait for 2 minutes. Just let us give it a try. Yeah, online students, just wait for 5 minutes. Some special efforts are going on. Okay, guys. So true positive. Let us understand what is true positive. So here two words are there. First one is positive and second one is true. So for your easy understanding, I'm saying two words. There are two words. Okay. You are having total two words, out of which the second word and first word. The second word is what you have predicted. What you predicted. That is the second word. The first word indicates whether it is a correct or wrong. Whether it's correct or wrong. The second word indicates what you have predicted. The first word indicates whether it is a correct or wrong. Now tell me whether this particular record, first record, whatever the record is there, the actual value is positive and predicted is negative. Now tell me what it has predicted. Negative it has predicted. Whether it is a correct or wrong, it is a wrong one. So it is called as F1 category. Now this one, what it has predicted? Positive. Whether that is correct or wrong? Wrong one. FP. It comes under FP category. Now this one, what is the category? True negative. This one, true negative. This one, false positive. This one, true positive. This one, false positive. This one, true negative. True positive. False positive. Simple. What is meant by true positive means actual positive, predicted also positive, is called as true positive, which is TP. How many TPs are there here? This is the one and this is the one. Two are there. Two are TPs. This is the TP and this is the TP. These are the two. So that is the reason here we have written two. What is meant by false positive means predicted positive, but which is opposite, wrong. Wrong means actual is negative. Actual negative and predicted positive is called as false positive. Oh, sorry, not this one. This one. False positive. This is called as false positive. And true negative. True negative means predicted negative. First, you see the second word. What are the second word is there? That is the predicted one. Predicted as negative. And true means actual also negative only. Both are same. Then it is called as true negative. This is the one. And N, again predicted negative. And actual is positive. Opposite to that, which is nothing but this one, which is Fn. Right? So that is the meaning of true positives, true negatives. Sir, instead of here COVID positive is there, so positive, positive, okay. Instead of positive, for example, I'm having yes. Yes and no's are there. True yes. What is meant by true yes? Actual predicted as yes. And it is also actually it is yes. Predicted yes with actual yes is called as true yes. Simple. Don't remember positive, negative word only. Concept, understand the concept. Here the positive word is there, so positive. So if negative word is there, negative. If yes word is there, yes sir. No word is there, means no. False no's. How many false no's are there, miss? Predicted as no and actual should be yes sir. Because both should be opposite. Then only it is called as false. Falsely predicted no's are called as false no's. Falsely predicted no's are called as false no's. Falsely predicted negatives are called as false negatives. Is that clear? Whether it is yes and no also same. Whether it is whether the person will accept the loan or reject the loan also same. Accept or reject, two words are there. Now in this accept or reject, true accept, false accept. True reject, false reject. We are having the words like this. It is not compulsory we have to use positive word only, negative word only. It is no rule like that. Is that clear, guys? Got the point? So this is called as with respect to true positives, false negatives, false positives, and true negatives. And this is the confusion matrix. Now, most important point will come into picture. If this is clear, because everything are dependent on the confusion matrix only. Next, further, whatever the evaluation metrics we are going to do, everything is decided based on the confusion matrix. Now, the next two words are clear, right? First word indicates whether you have done correct or wrong. Second word indicates what you have predicted. The second word indicates predicted value, not the actual value, predicted value. Remember, second word indicates the predicted value. The first word indicates whether it is a correct or wrong. Okay. In null and alternate hypothesis, that is hypothesis testing, we have used the first word called as incorrect or correct word. Second word, we have used the either accept or reject. Second word is accept or reject. First word is called as correct or incorrect. Here in this case, the second word is positive or negative. First word is true or false. That is the only difference. Right? Now, so the next one, sir, out of these four of them, which is important? In the interview, they'll ask you whether TP, FP, or FN, or TN. Obviously, we know that TN and TP are important because they are comes under accuracy. If the values are very high, means the accuracy is very high. If the TP and TN are high, means automatically accuracy is high. So your accuracy is equal to, what is accuracy formula? Correctly predicted data divided by total number of data points. What are correctly predicted in this total four of them? What are correctly predicted? TP is correctly predicted. TN also correctly predicted. These two are correctly predicted. Divide by TP plus TN plus FP plus FN. Overall, this is the overall. Only four options are there. Four of them I'm writing in the denominator. And out of them, these two are correct. So this one. Technically, this is the formula. TP plus TN divided by TP plus TN plus FP plus FN. Okay. Now, similarly, misclassification rate. Whatever the misclassification rate is there. Misclassified. What are the total data is TP, TN, FP, FN. Total, this is the data. Out of which misclassified are FP and FN. These two of them are misclassified. That is the formula wise. But same thing. If you apply formula also, answer is same. If you apply this one also, answer is same. Everything is same. One and only same. Right? Now, the question is, out of FP and FN, which is important? In the interview, they'll ask you, which is important? FP or FN, which is important? The answer is, it depends upon the project and it depends upon the problem, business problem. It depends on the business problem. For example, here in the COVID example, if you take, for example, the person is already having the COVID. Let us take this example. First, let us complete this one. The person is having already the COVID positive. And we have predicted as COVID negative. What happens? So he will die because he will not take the tablets or he will spread to others. Okay, either he will die or others will die. Right? So this is a dangerous one. Now, if the person is having negative, he is not having any COVID, but it was predicted as positive. In this case, what happens? So they are going to give the tablets. And the tablets are good tablets or not a good tablets, means they are okay because they are just antibiotics or with respect to multivitamin tablets. These tablets will not have any effect on the body. So for this COVID example, this is suited. In this case, which is more dangerous, means FN is more dangerous and we have to focus on the FN. For this example, case study of COVID example. For the COVID example, FN is more important. If the FN you have predicted wrongly and this number is more, your entire data analysis is waste. This should be as low as possible. Okay. For example, out of COVID patients, if you predicted these people more also, no problem. More number of people will be sent to quarantine. If it is lockdown 1.0, first case, if you take like that also, if the person is a negative person and you have predicted as positive also, you are going to send to the quarantine. And in the quarantine also, they are going to maintain the distance only, right? Though other COVID patients are there, he is not a COVID patient also. Distance will be there. Sanitization will be there. precautions will be there, everything will be there. If he is not having negative also, if he is negative also, though he goes to quarantine also, there also negative only. The negative only will be continued. He will not get positive in the quarantine because there the social distance is more. When compared to in house, the social distance will be more. And at the same time, they are going to give some kind of tablets or anything. So the precautions will be there. And at the same time, he is going to get the multivitamin tablets or some kind of antibiotics, something like this. Right? Now, coming to this, in this case, FN is more important in this case. Now, just to change the example to cancer data set. Assume this, actual the person is having cancer. Positive word says that cancer. Actually, the person is having cancer. Actually, the person is having cancer and you have predicted there is no cancer. What happens? He will die. So FN is again important. Okay. Now, actual, let us take like this. Actually, the person is not having no cancer. The person is not having no, actually the person is having no cancer. Okay. Today, some special efforts are going on from starting to ending. Now, pen is not working. Okay. So actual, no cancer. The person actually not having any cancer, but predicted as cancer. For non-cancer patient, if you give the tablets of cancer tablets, what happens? If you take to some kind of radiation or chemotherapy or something, what happens? His life will be decreased. Okay, cancer tablets are not like Dolo 650. We can't give as normal. Okay, we can't take as normally. Like they're not like body pains, they're not like multivitamins, or they're not like calcium tablets, or they're not like with respect to some others, right? So here, the cancer tablets are more dangerous. If you don't have cancer and if you take the cancer tablets, miss, it is going to impact the entire body, right? So here, FP also equally important. In this example, for the cancer patient data set, FP and FN both the plays the equal role. In the COVID example, only FN. In this example, FP and FN. So it completely depends upon the business problem, and based on that, whether FP or FN or both of them. It completely depends upon the business problem. Is that clear, guys? So we can't decide whether FP is more important or FN is more important. In the interview, they'll ask you which is more important, means you have to answer. It depends on the business problem. In some cases, FP will be more important. In some cases, FN will be more important. In some cases, both will be important. Can you explain me one example with one example, miss? Explain with a cancer data set. Or for example, banking data set. If you take a banking data set, actually the person will repay the loan, but you have not given the loan. That is loss for the bank. Okay, that is interest only will be loss. Okay, that is not a problem. But the person is a defaulter, but you predicted him as a non-defaulter and I have given the loan. What happens? Your interest amount, at the same time, the principal amount also will be lost. And it is going to be a loss for the company. Okay. So in that case, again, FP is going to play an important role in the banking sector. In that is completely depends on the business problem, which is more important and which is less important. Right? Now, coming to the next one called as precision. The next one is called as precision. How much precisely you have predicted? Precision says preciseness. Okay, you are having the precision for positive, similarly precision for negative. Guys, if you want to understand this one in a simple way, miss, the only thing you have to do is you should not write simultaneously. Easily you'll understand. 100%. Similarly, we are having the recall of positive and a recall of negative. Recall positive, recall negative. One will work with respect to the precision with respect to predicted values. One will work the precision with respect to actual values. Means in the denominator, positives, total, you have to take word called as total positives. Which positives you have to take? Here the precision is there. Precision is there means predicted. Total predicted positives you have to use. In this total, again positives only. Denominator is always total only. Total positive, total positive. But here the recall word is there. Whenever there is a recall word, you have to use actual. Now, what is the difference between these two? Total predicted positives means in this predicted positives, what is the total value? Total value 2 plus 4, 6. This is the total value. Actual positives are 2 plus 1. This is the total value of actual positives. This is actual positives. Total number of actual positives are 3. Total number of predicted positives are 6. So here that predicted positives means you have to see from the prediction direction. From the prediction direction, what is the total of predicted positives? 6. Denominator is 6. In this correctly predicted positive, numerator is correctly predicted positive. This one also correctly predicted positive. There is no difference in the numerator. So here total 6, out of which how many of them are correct? 2 of them are correct. 2 by 6 is the precision of positive. Out of this one, total is how many? 3. Out of 3, how many of them are correct? 2 are correct. 2 by 3 is called as recall of positive. Now coming to the precision of negative. Similar way, precision of negative. What I have told, precision of negative means first write the denominator. In the denominator, what you have to write? Total negative. Precision means predictor, actual. Predict. In terms of predict. Total predicted negatives. Total predicted negatives are how many? 4. Out of which correctly predicted negatives. Correctly predicted negatives. How many of them? 3. So 3 by 4. Means whatever you have predicted within your predictions, negatively correctly you have predicted 3 of them. And positives you have predicted 2 of them. Total 5 of them you have predicted. But 3 of them you have predicted out of 4 correctly. And 2 out of 6 you have predicted correctly. Means your precision is with respect to negative wise more. More negatively you have correctly predicted, but in the positives you have wrongly predicted. Right? Similarly, recall. What is recall indicates? Total actual negatives. Total negatives only, but this time actual. Inside that, numerator is correctly predicted negatives, which is nothing but total actual negatives are 7. Out of 7, how many of them are correctly? 3. So this is with respect to called as precision and recall. Precision for positive and negative separately, recall of positive and recall of negative separately. Is that clear, guys? Formula wise. Now coming to the formula wise, precision of positive. What is the precision of positive formula? What is the formula? TP divided by what I have to take in the total predicted positives. What are the total predicted positives? TP and FP. Because the second letter, whatever the P is there, everything you have predicted positively only. But out of which TP is correct one, FP is the wrong one. But predicted positively. So similarly, this one, precision of negative formula. What is the formula? Tn divided by Tn plus Fn. This is the formula for this one. So this is the formula, but concept, what is the concept means in terms of out of actual predicted positives, what are the predicted positives within that, how many I have predicted correctly? How much precisely I have predicted, preciseness of my prediction. For example, you have correctly predicted everything. Perfectly you have predicted 5 out of 5. What is your precision will be? 100% is your precision. Precision means preciseness. For example, I asked you to cut 1 mm. I asked you to cut 1 mm. You have cutted exactly 1 mm. How much precisely you have cut it? 100% preciseness. But I asked you to cut 1 mm. You have cut it 0.9 mm only you have cut. How much precisely you have cutted? 90% precision you have cutted. 10% you have left. That is the meaning of precision. Precision meaning cutting is already completed, but inside the cutting, how much correctness is there? Similarly, prediction also completed. Within the prediction, how much correctly you have predicted? That is the meaning of that. Now coming to the recall of positive. What is the recall of positive formula? TP, numerator is common. Denominator, instead of considering TP plus FP, TP plus FN. In the denominator, TP plus FN. TP divided by TP plus FN. This one is TN divided by TN plus FP. TN plus FP. This is the formula for this one. TN plus FP. This is the formula for recall of negative. They are formulas. Concept is out of actual, how many you have done correctly. That is the concept. Is that clear? In the Python coding, we are not going to do anything manually. Just we have to import and we have to give actual and predict. It will only do everything. But how it is doing in the backend, what is the backend code, how it is working, that is more important. Is that clear, guys? Precision and recall. Precision of positive is there. Precision of negative also is there. Not only precision positive, precision of negative also is there. In the textbooks, if you find only precision of positive means precision of negative also is there. At the same time, recall positive and recall negative also is there. And it completely depends upon the project, which parameter we have to work, whether we have to work on the accuracy or whether we have to focus on the misclassification rate or whether we have to focus on the precision or whether we have to focus on recall or whether we have to focus on the false negatives or false positives. Everything completely depends upon the project. And the business problem understanding only, you have to understand very clearly that one. For this particular project, which is more important and where I have to focus. Overall, if you want to focus means simply you are going to focus on accuracy. For example, banking people are there. They want to give the loans and they want to identify the wrong persons. They don't want to give to a wrong person. Means actual the person is a defaulter and you have predicted as a non-defaulter. That is a problem one. The person, actually the person, to be more precise, actually the person is Vijay Mallya and you predicted as SRK. Okay, example, which is a wrong one, right? This should be very low. In this way, you have this one should be very, very, very low. Okay, now, so here, that for example, the person is actually the person is a defaulter. The person is a defaulter, means who will take the money and run away. The person is defaulter and predicted as, you have predicted as non-defaulter. And you have given the loan. Okay, you have given the loan. You assume that this person also will pay the loan and you have given. Now he will take the money and he will fly away, right? And now the principal amount will be lost. At the same time, interest amount also will be lost. Now we have to give the loans to a right person. For the banking industry, this is more important. How much you have predicted, others are not important. This particular thing is more important. This should be almost close to zero. For example, I have applied multiple algorithms. Algorithm number 1, algorithm number 2, algorithm number 3, algorithm 4, algorithm 5. I have applied. Out of these 5 algorithms, which algorithm is best suited for my data? Miss, I'm going to focus only on this parameter. Which algorithm has given me the least value in this? That is the best algorithm, not with respect to accuracy wise. That is the business problem. That is their requirement. For example, the banking people has told that, okay, Shiva, not a problem. Some others people are also going to repay the loan now. Okay, these people will be there. Okay, ignore this one means then I have to focus on the accuracy. That's completely depend upon the project problem. First, we have to understand the business problem very clearly and for which parameter we have to work and we have to understand and we have to focus on that parameter and we have to do accordingly. And in the grid search CV, we have to identify the best parameters. Scoring also we have to do accordingly. Scoring is equal to accuracy means it will identify the best parameters which will give the best accuracy. Scoring is equal to pressure. If you give miss, it will identify the best parameter which will give the highest pressure. Scoring is equal to recall miss, it will identify the best parameters which will give the highest recall. Scoring is equal to false positives miss, it will identify which will give the highest false positives. So what are the scoring you are going to give in the grid search CV? It will identify the different parameters. It will try to substitute in the different values. And finally, it will try which gives the maximum value. So in that scoring, what you have to write miss that you have to decide in the business problem. According to that, you have to create the model. According to that, you have to identify the parameters. And according to that, you have to submit your project. Clear, guys? In the further, we are going to do almost 5 to 6 projects on classification algorithms. So there you can understand very clearly for different projects, what are the different types of evaluation metrics we are going to consider. And not yet completed. Next, we are having the sensitivity and specificity. The next heading is sensitivity and specificity. Data set is same. Now sensitivity and specificity. So the next one is sensitivity and specificity. The next one is sensitivity. Sensitivity. Specificity. Sensitivity and specificity. And we are having true positive rate, false positive rate, false negative rate, and true negative rate. And last ROC and AUC. So these are the things which we are having still yet to be discussed. And is that okay if I continue? Or should I stop and if are you guys going to practice? Okay, so let me stop here. Please practice. And tomorrow's class, we'll discuss this remaining part like sensitivity, specificity, and true positive, false positives, and ROC and AUC. All these things we are going to understand. Once we understand the evaluation metrics, then we